In the last movie, we looked at a procedure to compare the means of two different groups on a scale variable using what's called the independent samples t-test. On the other hand, if you want to compare the means of more than two groups, you would want to use something called the analysis of variance, or ANOVA. And although you can use ANOVA with two group comparisons, and there's a simple conversion formula between the ANOVA results and a t-test, it's more common to reserve it for times when you have three or more groups. What the analysis of variance does is look for any kind of difference between the means of the various groups. That might mean that group A is different from group B, is different from group C, or it might mean that A and B together are different from group C, or any of several other possible combinations. For this reason, you'll want to do a couple of things when you do an analysis of variance. First, you'll want to look at the group means, such as with a bar chart of the means, to see if any natural groupings emerge. Second, you'll want to do something called a post hoc test, that's Latin for after the fact, that can tell you where the differences specifically are. We'll look at both of these in this example. For this demonstration, I'm going to use the Google searches information in searches.save. And to get the analysis of variance, what we need to do is go up to Analyze, to Compare Means, to what's called the one-way analysis of variance. It's called one-way because we're going to use a single categorical variable or factor to differentiate between the groups. This is because there's other versions of the analysis of variance where you can have more than one categorical variable. We have just one, so this is the one-way analysis of variance. You can check more than one variable at a time by putting it in the dependent list. These are the outcome variables where you're looking for differences. In this particular case, I'm just going to use one, and I'm going to use the relative interest in searching for the NFL in Google. And I'm going to look for regional differences on that. So I find the regions of the U.S., that's Census Bureau regions, and I put that under factor. In the analysis of variance, the categorical variable is called a factor, and the categories within that variable are called levels. So we have four groups within the Census Bureau region, so we'll have four levels in the factor of region. Now we come up and we check a few other things. The first possibility is contrasts. Now, this is something that we can ignore because it's for specialized comparisons like changes over time or mathematical combinations of groups, something called planned contrasts, and we're not doing any of that, so we can just ignore this one for right now. I'll press cancel. The second one that we want to look at is called post hoc, again, for after the fact. Now we have a lot of choices here. The most common choices are what are called the Bonferroni and the Chaffee tests. They're common, but statistically speaking, they're not perfect. They tend to be a little over-conservative, and their output can be a little complicated in SPSS. For that reason, I prefer to use a test called the Tukey test. It's named after John Tukey, statistician, and its full name is actually the Tukey Honestly Significant Difference Test, or HSD test, which is what you'll see in the output. So I'm going to click on the Tukey test, then I'll just come down and hit continue. Now let's take a quick look at the other options. I click on the options, and I can get descriptive statistics, which are helpful for this kind of analysis. I can also get a means plot. It's a simple line plot, but it's still helpful for looking at a graphical representation of the differences between the means. So I'm going to click on means plot, and then I'll click continue. Now we're back at the main dialog, and I'll click OK. And here we have several tables that show up. The first one is the descriptive statistics. It gives me the mean for each of the four groups in this factor. It tells me, for instance, that the relative interest in searching for the NFL in the Northeast is below average. It's negative 0.36. That means they're 1/3 of a standard deviation below the national average for states in relative interest in searches for the NFL. The Midwest, on the other hand, is much higher. It's 3/4 of a standard deviation above the mean, with a mean of 0.75. The South is slightly below zero at negative 0.07, and the West is, again, about 1/3 of a standard deviation below zero at negative 0.33. The next column over is the standard deviations, and they go from about 0.8 to 1.1. They're not hugely different, and they feed into the standard error which is used for the inferential tests, but otherwise we can ignore these. Now, this is the analysis of variance table, or ANOVA table. And what it does is on the top corner, it tells me that it's looking at the variable NFL. And you see that it's statistically significant. In the last column under SIG, it has 0.20. That's the probability value for these. And the general guideline is if it's under 0.05, it's statistically significant. Beneath that are the results for the Tukey post hoc test. Now this first table of multiple comparisons is kind of complicated and we can ignore it. Let's go to the one beneath it. This is what's called homogeneous subsets. And what this does is it places the groups in like with like. And this tells us that the Northeast, the West, and the South are all relatively similar to each other in terms of their searching for NFL in Google. You can see they all have negative means. On the other hand, the second group is kind of interesting. Midwest is much higher, so that makes sense. The South is still with it, and the reason for that is even though the South and the Midwest are different from each other, they still have some overlap with the standard deviation, so they are not significantly different from each other. And this becomes clear if we go down one more and look at the means plot. Here you can see that the Midwest is much higher, and the South, while it's down lower, is still above the West and the Northeast. So the Northeast, the South, and the West all form a group, but the Midwest and the South actually combine as well. But the point here is we're able to do a lot of comparisons and get a lot of information from this one test. The analysis of variance is a very flexible and useful procedure for comparing the means of several different groups. In combination with a graphical analysis and post hoc tests, you can get a lot of insight in a little bit of time. In the next movie, however, we'll backtrack just a little to look at a variation on the t-test, one in which you can look at changes over time for a single group of people, or look at differences between two different variables using what's called the paired t-test.